Hi, everybody. My name is Logan Kline. I recently got my master's degree at the University of Maine in the program of Ecology and Environmental Science. And while I was there, I worked on a larger project looking at using um, artificial intelligence in order to detect nesting seabirds in imagery of said seabirds. Um, Today, in particular, I wanted to talk about a smaller portion of that project where I created an ArcGIS online dashboard that I developed as an interactive tool to visualize and disseminate information about remotely sensed colonial nesting seabird data. So owning in a little bit more than just on the artificial intelligence here. So before I talk about the dashboard, I wanted to introduce why I focused on monitoring colonial nesting seabirds, some traditional challenges of monitoring those birds, and some remote sensing solutions that lead to why we use the GIS dashboard. So colonial nesting seabirds like herring gulls, double-crested cormorants, and great black-backed gulls, like you would see here, are birds that are extensively using oceanic and coastal resources and nest in groups of two or more birds. They may nest in colonies of single or multiple species, and they're highly sensitive to shifts in ecosystem conditions, which makes their individual and colonial success potential indicators for marine and coastal environments. So, as part of the project that my master's research contributed to, our team developed methodologies to assist biologists in Maine who monitor the status of seabird populations on coastal islands. And there are inherent issues in monitoring nesting birds. For instance, two common methods of surveying colonial nesting seabirds include ground-based counts and aerial counts. And in ground-based counts, observers are walking through the birds, exposing them to disturbance, possible crushing of eggs, and exposure. And aerial counts that are prone to visibility errors. So you can imagine being in a plane, trying to count each and every gull that you're flying over, leads to a couple of different problems there, much of which is just due to visibility and being able to actually see those birds. So a solution that exists for addressing these type of problems that you get with ground counts and aerial counts, they really lie in remote sensing. The part of the slide that I want to focus on is using plane-based imagery in order to capture images of these nesting birds, creating a snapshot of them at a moment in time, and allowing you to do a little bit more analysis off of those images than you are if you were just coasting in an airplane above these birds. So as what I mentioned, one of the benefits of plane-based remote sensing of colonial nesting birds is that there can be a moment in time that's captured over a large imagery footprint. And this extent presents some issues with data collection and presentation. For instance, interpreting aerial imagery is really time consuming. It took us 900 some odd hours to look over 240 islands and count the birds on them. Second, depending on how data collection is structured, the process may generate a lot of files from several people across different storage devices, making data aggregation difficult. And there are questions about the best way to present results from a large data set to our various stakeholders. In our case, it was Fish and Wildlife Service and the Maine Department of Inland Fish and Wildlife. So for the remainder of this presentation, I want to discuss the ways that we addressed, what's best to present the results from a large data set to stakeholders. And our solution was GIS. So now that I've given a little bit of context for why we might use remote sensing in GIS in monitoring seabird colonies, I want to give some background on our data sets and how I approached the task of displaying the data. So our data was aerial images that came from a U.S. Fish and Wildlife Survey that was conducted in 2019 that covered the Gulf of Maine. So a plane flew over the Gulf of Maine with a really nice camera attached to it at roughly 310 meters above ground level, which gave us a imagery resolution of about 2 centimeters per pixel ground sampling distance. Imagery was captured for approximately 274 seabird nesting islands during the peak breeding season, and images were orthorectified, georeferenced, and mosaicked into a really large raster data sets. And the imagery from 2019 added to a data set that contains aerial imagery captured roughly every 5 years. So imagery also existed for 2008 and 2013. We'll just deal with the 2019 images today. So what ended up happening was 3 independent observers using ArcGIS Pro went through these images, marked each bird's to species and to behavior, and then we We counted the islands 2 to 3 times in order to make sure that there was agreement between each of these observers on what they were calling a certain bird as a species or behavior. So now I just want to run through a little bit of a demonstration showing what this tool ended up looking like. So I've got here a little video to play. And we'll do that. Upon opening the Gulf of Maine Seaboard Inventory dashboard, you can see a few key features. First, the map displays the extent of the Gulf of Maine, and points are visible where birds have been counted. To the right is a legend of the species that have been detected in the form of 4-letter codes as defined by the Institute for Bird Populations. On the left-hand side of the dash, we have 2 graphs. The top graph displays the 5 most populous birds across the Gulf of Maine and their numbers in terms of behavior. Hovering over the bars shows we have about 15.4 thousand roosting herring gulls, 13.7 thousand nesting herring gulls, and 440 flying herring gulls that were detected across the Gulf of Maine in the 2019 aerial imagery. On the bottom, we have the same sort of graph that updates given the geographic selection on the map. Let's say we want to see the count for birds on Appledore Island. We can search for this island by name up here. And then we can draw a selection around that island. And we'll see that the bottom graph is updated in order to show the counts for Appledore Island in the summer 2019 data. For instance, here we have 607 nesting herring gulls, 389 roosting herring gulls, and 16 flying herring gulls that were detected on Appledore Island in 2019. Users can also search for islands by the Coastal Island Registry number. So for instance, we can look for that of Damaris Cove Island, which is 65280. And we're taken over to Damaris Cove Island. A land cover layer provides context necessary to understand where birds were using the land. Users can also filter by species and behavior. For example, if I only wish to see where nesting great black-backed gulls are on Damaris Cove, I can filter for that using these category selectors up here. So great black-backed gulls, and we're only looking at the nesting birds. Then I could see where herring gulls are in comparison. So change this to herd. And you can see a dramatic difference in where the herring gulls are utilizing the land to nest on Damaris Cove Island versus where the black-backed gulls are using the same land.